last time.
3, 2, 1, 0. That's a double. Yeah.
That's the cooler star. Yes! Yes!
Sistine and Deuce launched without a hitch. A perk of using sounding rockets is they fall back to Earth, so you can reuse the instruments. So, we're headed into the outback to find them. Luckily, wildlife in Australia is known for being really friendly.
Another creature of my nightmares.
There's some life biting me right now. There he is. Look at him.
Oh my god, that's worse than I thought.
We're here in Australia! And we're gonna launch some rockets. We're following 2 NASA rocket missions as they try to understand how stars make the planets around them suitable for life. I'm Miles Hadfield, and in this episode, we're gonna go find some stuff that just fell from space. The morning after each launch, a team is sent out to recover the rocket and instruments. We just got word that we are going to be able to go on one of the recovery flights in the helicopter, so we popped out of bed and we're driving now to the Goddard airport. During flight, the rocket breaks into 4 separate parts, each of which lands in a different location. The team is tasked with finding and retrieving them all, and not letting the crocs retrieve them along the way. Using math, maps, and experience, the recovery team leader Peter Elsner has a pretty good idea of where each piece has landed. But winds can push the falling pieces off track, making them difficult to find. The first thing we're looking for is one of the payloads, which houses all the scientific instruments. Luckily, it's equipped with a bright orange and white parachute, which should help it stick out. Not there. Not there either. Nope, that's not it. There we go. Sure enough, we spot it right where Peter predicted. And it looks like the parachute gave it a nice soft landing. The nose cone was just a few miles away, but its landing wasn't so soft.
This is a wizard's hat. Yeah. He's not gonna wear it now.
The helicopter then carries both the nose cone and payload back to the range before being shipped back to the US. Both Sistine and Deuce have made several trips to space before. Now, they're ready for retirement. After some repairs and careful testing back home, they'll live out their days in the lab, helping calibrate new instruments and analyzing laboratory data. With that done, we're off to find one of the second stage motors, which takes the payload all the way to space. But unlike the payload, it doesn't get a nice parachute to soften its landing. Yep, it's really in there. The team marks its location and flies back out the next day to dig it out of the ground. And then filling that hole right back in so as to leave as little trace as possible. The next day, I joined the recovery team on foot as we hike out to find the first stage motor, which didn't fall too far from the range. We were led by Micah and Boaz, 2 Dimaroo rangers who knew the area, and how to recognize the animals that could kill us.
Dangerous or?
Dangerous. 10 grams.
Really? Hey, I didn't say it was a big snake. Now watching my feet a little more carefully.
Nice size ant mound.
Yeah, look at that guy. He's cool. After about a half hour of hiking, we finally found it.
Wow, there it is.
It may only burn for the first 6 seconds after launch, but it still manages to get over 2.5 miles high. That's one heck of a fall. Peter assessed the tools we'd need and then radioed in the list to the helicopter. So right now we're digging out parts of the motor that are lodged in the ground. One, 2. Nice! That thing's heavy. That's a fin. As we waited for the helicopter, Peter gave an impromptu tutorial on rockets. With sound effects.
Takes off. Big parachute comes out, blows over there. So then we have to find it.
I think we just got our explanation for the video of how a sounding rocket works. As the recovery efforts wrap up, it's time for us to head home. But for the science teams, things are just beginning. A year after launch, both teams are getting ready to publish their results. But we convinced Kevin to give us some hints ahead of time.
Hi, Miles. Long time no talk. How are you doing?
I'm good. Mostly just eager to hear about what you've learned.
Yeah, so we've been taking a look at the cysteine-induced data and trying to compare that to the ultraviolet brightness of our sun. And we're finding that these Alpha Centauri stars are maybe 2 times brighter, maybe 2.5 times brighter in the ultraviolet than our sun.
So what does that mean for the habitability of a planet around stars like Alpha Centauri A and B? Would an Earth-like atmosphere survive those sort of conditions?
This probably means that the upper atmospheres of planets around those types of stars are just going to be a little bit hotter than what we have here on Earth, but not to the point where the atmosphere is rapidly evaporating and it's changing its composition drastically over time. I actually think this is pretty good news for the ability of your average rocky planet around an average solar type star to hang on to its atmosphere and probably be a pretty good candidate for the search for life.
That's amazing. So what about biomarkers or signs of life on planets around stars like that?
It looks like the biomarkers that we would expect here on Earth, things like molecular oxygen, methane, those all look like they're probably going to be pretty good on planets around stars like Alpha Centauri as well.
That sounds really promising. So how do you think these findings are going to impact the search for habitable worlds going forward?
So that's a really good question, Miles. NASA has recently started a new mission concept called the Habitable Worlds Observatory. And this is going to be the mission that I think finally allows us to determine if we are alone in the universe or if there are signs of active biology on planets beyond the solar system. And I think what some of the results from DEUCE and Cysteine are telling us is that orangish and yellowish stars are probably going to be the best environments in which to look for life as we understand it here in the solar system.
That is so cool. Thanks for talking with me, Kevin, and giving us this sneak peek at your results.
Great to talk to you too, Miles. See you next time.
After this adventure with Cysteine and DEUCE, the night sky doesn't look quite the same to me anymore. Hanging out with these rocket teams has shown me that we're in a time like no other, where our capabilities for discovery are starting to catch up to our imaginations. Somewhere, orbiting a far-off star, is there another planet brimming with life? Or is our habitable world the only one that's actually inhabited? We've never been closer to finding out.